And once the energy is gone from the automaton, it reaches its final point. And if you think in linear equilibrium terms, you think in terms of automata, which was a type of technology that in the 18th century was elaborated to an incredible degree, but nevertheless it produces the wrong vision of what nature is, and therefore the wrong vision of what the relationship between nature and society are. Once we begin introducing something like the steam engine, which is already a nonlinear, far from equilibrium machine, once we begin to introduce transistors, which are also nonlinear, non-equilibrium technologies, once we begin to introducing the whole variety of modern technologies which are nonlinear and non-equilibrium, that vision of the world, that vision of what nature is, and that vision of how cities, how communities, how organizations fit within that order begins to change. Our actions, our ways of affecting nature are not going to be linear. They can have non-linear effects. A desalinization of the North Sea, for instance, which would stop the Gulf Stream from bringing warm air into Europe, would have enormous effects, even if the cause was simply a slightly more melting of the Arctic, a slightly more potable water flowing into the salinization point, where there's got to be enough salt for the Gulf Stream to go down. But then the consequences would be entirely nonlinear, entirely non-equilibrium, in the sense that the capacities of the planet to be affected are not being taken into account. We think in terms of, well, if we simply reduce the amount of pollution that we put out, there will be a linear consequence. But sometimes we do things at sensitive points in the planet without considering the capacities to be affected of the planet, in which a slight action on our side can have enormously amplified consequences. I believe that it is one of the philosophically important points of our time to become aware of those sensitive points around the world, to map